Okay, this is a solution for CCEA C2 2017 question 8, which is a question which involves circles, a wee bit of circle theorem knowledge and a bit of trig. Okay, what we've got here, it says in figure 1 below shows a framework for part of a stained glass window. A, B, BC and CA are all tangents to the circle, centre O and radius R. It also tells you in this first bit, and I'll label this for the I'll not label this, actually I'll draw this diagram again, but it tells you that AB is 20, so that means this bit here is 20, AC is 16, and BAC, very importantly, is 90 degrees, and what you've got to do is find the exact length of BC. So it's just a right angle triangle, so you can just use Pythagoras Theorem. So for this, I'll just do that diagram out again. You've got your B, you've got your A, we know AB is 20, you've got your right angle, you know AC is 16, and then BC is what we're trying to find. I'm just going to call that X. It's my hypotenuse, so X squared is equal to 20 squared plus 16 squared. Fire that into your calculator. You will get 20 squared is 400, 16 squared is 256, that's going to be 6x squared equals, 656, which means X is equal to the square root of 656. If you do it on your calculator, square root of 656 and press equals, you will get an exact value of 4 root 41, and that's what they wanted, as I said, exact in the question. The next part of the question says, hence show that R is equal to 5.19. Now it took me a wee minute to figure this out, exactly how I was going to do this, but it's using the fact that the angle between a tangent and a radius is 90 degrees, and also a lesser known circle theorem, which is about tangent kites. So I'm just going to draw on any of my radius. So I've got a radius here from the center, and that's 90 degrees. A radius here from the center, and that's 90 degrees. And I've got a radius from the center to here, and that's 90 degrees. Okay, so they're all, that's each one of those, it would be a radius. So they're all R. Okay, and this also, importantly, this wee length, there's a radius here. Parallel to it is this. So this length, very importantly, is going to be R as well. And I think that happens again. Yep, this length here is R. Parallel to it is this one, same length. It's also going to be R. So which means, remember, we knew, first of all, that AB, the whole length, was 20. So I can label this part of it to just be 20 minus R. And also, well, forget it, come back to that in a second. And also then this whole length here was 16, which means this bit here is just going to be 16 minus R. Okay, now we're into our tangent kite properties. So this we shape by one of our tangent kite properties, because AC and BC and AB are all tangents. Those two, that wee length from here to here, I've just marked with double lines, they are both equal in length, which tells you as well then that this length here must be 16 minus R. Likewise, this length by your tangent kite property is equal to this length, so it's going to be 20 minus R. Alright, and remember, we also know what the total length of this is. The total length of this was, from the first part of the question we did, was 4 root 41. So we have got a relationship between 4 root 41 and the 20 minus R and the 16 minus R. So we can use that to answer the next bit. So the part 2, I'm just going to do it over here where I can see the diagram. So part 2 asks us to show that R was equal to whatever it was. I think it was 5.19, we'll see in a wee second. But we know then that 4 root 41 equals, and it's going to be 20 minus R plus 16 minus R, which works out to be then, if I move the two R's across to the left hand side, I'll have 2R is equal to 20 plus 16 minus 4 root 41, and I will just get that, I'll hit that into my calculator. So 20 plus 16 minus 4 times root of 41 press equals, and I will get 2r is equal to, I press my SD button here, and I've got 10.38750305 divided by 2, and I got an exact value for my r is equal to 18 minus 2 root 41, and press SD. Hopefully it is what we want, and it is 5.19 centimeters, and that was two decimal places as required. The last part of the question says, find in radians the angle ABC. Now, unfortunately, this bit, if you're looking at the current specifications of A-level maths, radians doesn't come up in the AS level, so we don't really have to do that, but I'm just going to show you how you would find the angle. And to get radians, you just, on your calculator, radians is just another, for anyone who hasn't seen it yet, radians is just another measure of turn. So you have 360 degrees in a full revolution. You have 2 pi, so 360 degrees is equivalent to 2 pi radians is what it is. But to work with it, all you have to do is hit mode on your calculator, or shift and mode maybe, and then select, there's an RAD mode, whatever one that is in your calculator, and that's your calculator in radians mode. And then you just find the angles just the same as you would have using your inverse cos and sine and tan and so on. Okay, so find the angle ABC. Where is the angle ABC first of all? The angle ABC is in this triangle. So ABC, so if you can imagine, I want to find this angle in here. That's what we want to find. Now what we can do is split that angle in half, and I could find that angle, which is really going to be theta over 2. And I could find that because remember, I now know my radius. Oops, wrong one. I now know my radius, and I know then I can work out what 20 minus r would be. So it'll just be a bit of SOHCAHTOA. So I'll do it up here. I know it's a bit of a mess this now, but up here I will say that is my opposite side, so that's my O. That is my adjacent, so I'm going to use, I've got my O and my A, so I'm going to use TOA, so which stands for, remember, tan of theta is equal to opposite over adjacent. So in this case, it wasn't theta, it was actually theta over 2. And it wasn't the opposite, it was my R, and R was, and we're just going to go for this version we had over here. There's a long, well, we'll just go for 5.19. Just for the purpose of this video. If you're doing this properly, you do it a few more decimal places before you're working out. And then my adjacent was 20 minus 5.19. Do tan to the minus 1. Now your calculator's in radians mode of that. So tan to the minus 1, fraction button then, and put the 5.19 on the top line. And bottom line, put 20 minus 5.19. And, oops. So 5.19, and then bottom line was 20 minus 5.19. And we get theta over 2 is equal to 0.3370657 ... which means your theta is 2 times that. So 2 times that is 0.674 to 3 sig figs. So that was your answer to part C of that question.